Practical method for determining the cutting speed, F, millimeters per minute, for a CNC polystyrene cutting machine. The speed depends on many factors, including the type of polystyrene being cut, its density, whether it is extruded polystyrene, the diameter of the cutting wire used and its temperature during cutting, the precision you want to obtain and, finally, the ambient temperature where you are working. The wire I am using is nickel chrome with a diameter of 0.2 mm and has an electrical resistance of approximately 30 ohms per meter. It is ideal for precise cuts in the thickness of the casting. The kerf is approximately 1 mm for a wire length of 60 cm at a supply voltage of 32 volts, set an absorption of approximately 0.5 amps, which is a good starting point. As you can see from the video, cutting by hand is slow but precise. The wire does not burn the polystyrene but melts it, and the wire should never be red in color due to the temperature. In this video, the temperature of the wire is too high, the current is set to 1 ampere, the wire is too hot, you can see that it burns the polystyrene and smokes, the cut would be ugly and uneven. It is important to keep the wire clean. When it is hot, simply wipe it with a piece of cotton to remove any traces of melted polystyrene. Don't try this yourself, but if you touch the wire briefly, it will not burn your fingers if it is set to the right temperature. Now it's time for the real test. Take a sample of polystyrene for which you want to find the cutting speed, measure its thickness, preferably more than 40 mm, in my case it is 50 mm, with the wire not hot, place it on top of the wire and check that there is space for its thickness under the wire. The length of the piece of polystyrene can be about 40 cm, and the width about twice the thickness. You will probably understand from the video that the piece of polystyrene is cut by its own weight alone. Take a chronometer and measure the time it takes for the polystyrene to be cut. Calculation of theoretical speed. Speed equals thickness divided by time. Speed equals 50 mm divided by 22 seconds equals 2.27 mm per second. Normally, speed F is expressed in millimeters per minute. So we multiply 2.27 by 60 is equal to 136.2 mm per minute. To be on the safe side, I multiply this value by 0.9. So, 136.2 times 0.9 is equal to 122.58 mm per minute. I enter the value into the CAM program, CDEV CNC Foam or GRBL-GRU, F equal to 120. The speed found with this system is only indicative, you will probably have to make small adjustments. I have been using this system for several years and it has always helped me a lot.